Assalamualaikum, my name is Muhammad Alif bin Muhammad Saman. Nombor metrik 14 GKM 19F1019. My part in presentation is objective. Part 1, objective. Understand the basic of force, mass and acceleration. Newton of second law. 2. Know and use the equipment for experiment. 3. Analyze the result for the measurement. 4. To vary Newton's second law. Part 2 of me theory or introduction. Newton's second law of motion given to the difference of object for which all exerted force are not balanced. The second law changes that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object is acceleration, the acceleration of the object is acceleration. As the mass of an object is acceleration, the acceleration of the object is depression. According to Newton's second law, acceleration is product when a force acting on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. F for force, M for mass, A for acceleration. Formula F per m per A. Speed is the rate of change in distance. In other words, it is how fast the distance changes in 1 unit of time. In mathematics, experiment can be calculated from the following formula. Velocity, distance per time unit, m per s. Velocity is the rate of change in displacement. It is how fast and displacement change in 1 unit of time. Acceleration is a change of velocity. Acceleration A, velocity per times unit ms negative 2.
Apparatus and equipment that we use on the lab. First one is we use the scales to measure the weight of item. Second one is we use a slotted weight. The function of slotted weight is to increase and decrease the load. Third one is we use the meter ruler. Function of the meter ruler is to measure the length of an object. The last one we use a stopwatch to amount the time that elapses between its activation and deactivation. Safety precaution. Please do not do the experiment without lecturer supervision. And secondly is after finish the experiment, make sure to clean the equipment that we use and put it back at the place that we take it. Okay, thank you.
Hi, I will tell you guys about procedure and result. So about procedure, we got 5 steps. Step 1 is set up the apparatus and material as shown in figure 1 below. Step 2 is record a value of M1 and distance of H, constant value. Step 3 is release a system from 0 to N and record a time when M1 drop down. Repeat this procedure of different tests. Step 4 is repeat this procedure with different value of M1. And lastly, step 5 is record the result at below table. So the next is result. Result we got we use 0.1 kg, 0.05, 0.02, 0.01 and 0.005 kg. For 0.1, the first we got 0.97, second is got 1.46, third 0.97, and for AVG we got 1.13. Velocity we got 0.18 for 0.1 kg, and acceleration we got 0.16. For 0.05 we got first time 1.45, second we got 1.21, third we got 0.91, and for AVG we got 1.19. For velocity we got 0.17, and acceleration we got 0.14. 0.02 first time we got 1.13, second we got 1.53, third we got 1.12, and for AVG we got 1.29. So for velocity we got 0.16, and acceleration we got 0.12. For 0.01 for first time we got 1.04, second we got 1.28, third we got 1.29, and for AVG we got 1.2. For velocity we got 0.17, and acceleration we got 0.14. For lastly for mass 0.005, first time we got 1.54, second we got 1.61, third we got 1.36, and for AVG we got 1.47. So velocity we got 0.14, and acceleration we got 0.1. So for test 2, we will use height for 0.3 meter. For mass, the same like test 1, we got 0.1, 0.05, 0.02, 0.01, and 0.005. So for 0.1, for timetable for 1 we got 1.05, for second we got 0.96, for third we got 1.13, and for AVG we got 1.05. For velocity we got 0.29, and the acceleration we got 0.28. For 0.05 kg, for the first time we got 1.13, third we got 0.88, and third we got 0.89, and for AVG we got 0.97. For velocity we got 0.31, and acceleration we got 0.32. For 0.02 kg, for first time we got 0.72, second we got 0.8, and third we got 0.97. For AVG we got 0.83. For velocity we got 0.36, and the acceleration we got 0.43. So the fourth we will use 0.01 for kg, and first we got 1.06, third we got 1.06 also, and third we got 1.21. For AVG we got 1.11. For velocity we got 0.27, and the acceleration we got 0.24. For lastly we will use 0.005 kg. For the first we got 1.21, second we got 1.21 also, and the third we got 1.41. For AVG we got 1.28. For velocity we got 0.23, and the lastly acceleration we got 0.18. Yes, the data we will use to plot the graph like this. For the table 1 we got like this, and also the table 2 got like this. So the slide we will use. So next,
for the discussion is from the result we can easily see the relationship between position, velocity, acceleration and force. Acceleration is the rate of change of position. It is also easy to see the force is directly proportional to acceleration, Newton's second law. And for the conclusion is, in conclusion, Newton's second law provides the explanation for the behavior of objects upon which the forces do not balance. The law states that unbalanced force cause objects to accelerate with an acceleration that is directly proportional to the net force and inversely proportional to the mass. We also get a lot of experience and know how to use the equipment from the lab.